Hi, my name's Bruce, and this video is about boring tapers. I'm making some clamps to mount a die grinder on my lathe so I can turn it into a tool post grinder. This is the die grinder, and I figure this is a nice section to make clamps to mount it with, but it's tapered. It's actually it's 12.5 thousandths of an inch per inch. I don't know what that is in degrees, have to work it out, but it's just a little taper. So I figure if I make clamps with a cylindrical bore, clamp here and here, it might slip because the clamp would only be gripping on the very edge. So I want to bore the clamps to the same taper as this, so I have to set up the lathe to bore a 12.5 thou per inch taper. So what I have is a dial on the compound to measure the compound travel axially, and then I've got a mag base with another dial against the end of the cross slide, which is parallel to the lathe axis, so that as I travel the compound, this should go uphill or downhill, whichever it is, by the 12.5 thou per inch. So in 1 inch this should change by 12.5 thou, and to measure that inch I'm measuring on this. So let's do it. It's zeroed here and zeroed there, and the tens counter is 0. So now off we go. And that's coming up to 10 tens on the big dial, 0 on the big dial, and the little dial is now reading 13.5, just over 13.5, a needle over 13.5. Now that's just about where I want it, because I wanted 12.5, but I took the trouble to measure this surface here on the cross slide, and it's not perfectly parallel to the lathe axis. I put the dial gauge on the bed of the lathe and then traveled the carriage, and this is actually about a thou, 1.4 thou per inch not square to the axis of the lathe. So I added that in. So what I want for 12.5, instead of 12.5 in 1 inch, I want 14, and it's reading 13.6 or something like that. So that's close enough for me, I think. But anyway, that's how I'm doing it. Hopefully it will fit. You're probably wondering about cosine error too. So, but in fact it's not important in this case. So here is the taper triangle. I want 12.5 thou per inch. So I want 12.5 thou per inch. But what I'm measuring with the big dial is this side of the triangle here, not this side. And this side's longer. So in fact what I'm measuring, the 1 inch that I'm measuring here, is not 1 inch, it should be something different. So in actual fact, if you do the math, this should be, is it one? There, that's what it should be. And my 12.5 thou should be 0.01, what is it, 2499. So you can see that I can't even measure that. So that's not an error, that's, I need to consider basically. So in this particular taper, I don't need to worry about cosine error. But it can be significant for different angles. If the angle is bigger, it becomes significant. So let's take a Morse taper, for example, which is, most Morse tapers are 5/8 of an inch per foot, which is, let me see, 0.052 thou per 1 inch. So if I was doing a Morse taper 3 or a generic Morse taper, I would want 52 thou here per inch. Now what would this long side be that I'm actually measuring? It should be 1.0013. Now that's starting to be different. I can measure a thou. However, the 12.5 thou, no, I'm now doing 52 thou. And that goes to 0.0519, so 51.9 thou. A tenth of a thou difference. I would struggle to measure that, so it's probably not significant for the Morse taper. But if the taper was 20 degrees for argument's sake, this figure here would be 1.064 inches, and I'm measuring 1 inch. So this dimension here for a 20 degree should be 0.364 inches, and I'm measuring 1 inch instead of 1.064, so that really should be 0.342. So that's now 22 thou different. So that's becoming significant. So small tapers, cosine error, insignificant. But as the taper increases, gets steeper, cosine error, something to consider. And this is how the tapers turned out. You can barely even see that there's a taper there. It turned out to be 0.716 degrees. And for fit, it stops about there. But if you turn it over, the way the taper goes, it's a beautiful fit on that taper, and the one at the other end, when it'll just try to start with the small side first, and then, ooh, squeak, nice, beautiful fit. So it worked really well. And here is the finished article in action, doing some tool post grinding. For simple angles, I like to use an angle plate, and I found this big magnet, so I just attach the angle plate to the compound and then dial it in either on this surface using the cross slide, or on this surface using the carriage. That's it for this video. I hope you have found something interesting. Bye for now.